Welcome to a new section. Today we are going to study electric dipole. What is an electric dipole? An electric dipole is a pair of equal and opposite charges, that is minus q and plus q, separated by a small distance d. That is, it is a combination of two equal charges minus q and plus q separated by a small distance. This is called electric dipole. We are going to study more about electric dipole. First, we are going to study about electric dipole moment. Electric dipole moment is a vector quantity used to measure the strength of an electric dipole. So, this electric dipole moment is used to measure the strength of an electric dipole. The magnitude of the dipole moment is mathematically equal to the product of magnitude of one of the charges and the distance between the two charges. So here P is the electric dipole moment, Q is the magnitude of one of the charges. We know both the charges have an equal magnitude, and D is the distance between these two charges. We know electric dipole moment is a vector quantity. So here D is a vector quantity. That is, D should have a direction. Conventionally, the direction of D is taken from minus q to plus q. So the direction of electric dipole is taken from minus q to plus q. Therefore, the direction of electric dipole moment is also from minus q to plus q. In chemistry, this electric dipole moment is mostly denoted with the letter mu. So I can write mu is equal to q into d. What is the SI unit of electric dipole moment? We know it is the product of charge and distance. Therefore, SI unit of electric dipole moment is Coulomb meter. That is the SI unit of charge and SI unit of distance. So we got SI unit of electric dipole moment is Coulomb meter. Now we are going to study the second term, that is axis of dipole. Axis of the dipole is the line along the direction of the dipole moment. So we know the direction of the dipole moment is from minus q to plus q. That is, this line along the direction of the dipole moment is the axis of dipole. That is the line that joins minus q to plus q. Now the third term we are going to study here is center of the dipole. Center of the dipole is the midpoint of locations of minus q and plus q, and we know it will come here. So I am denoting it as O. Here O represents the center of the dipole, that is the midpoint of locations of minus q and plus q. So that this distance is d by 2 and this is also d by 2. So this O here represents the center of the dipole. Now let us understand something more about it. What will be the net charge of the dipole? We know the net charge is the sum of the charges. So what is the net charge? Here we know it consists of two charges. One is minus q and the other is plus q. They are equal but opposite. So the net charge is always 0. For an electric dipole, net charge is equal to 0. But we know there exists electric field due to the electric dipole. Why? We know the electric field at a point is the vector sum of the electric fields due to these charges. Since these two charges are separated by a distance, there exists a net electric field. We already studied magnitude of electric field due to a point charge is given by the equation kq by r square. What will be the electric field at a point due to this electric dipole? We already discussed it is the vector sum. So the resultant electric field at a point due to an electric dipole is equal to the vector sum of the electric field due to this plus q charge, I denote as E plus the electric field due to minus q charge at that point. So the resultant electric field is the vector sum of the electric field due to plus q charge and minus q charge. What happens if r is far away? That is, r is much greater than d. In this case, you can see d will be very negligible. So the electric field due to plus q charge is almost equal to the electric field due to minus q charge in magnitude. But we know they are in opposite direction. So they will almost cancel out. So as a result, the net electric field at a point far away from the electric dipole is 0. So the resultant electric field at a point far away from the electric dipole is 0 or negligible. We will study more about this electric field due to electric dipole in another section. Now we are going to do a numerical, which is question number 9 in the exercise. two charges QA, which is equal to 2.5 into 10 raised to minus 7 Coulomb, and QB is equal to minus 2.5 into minus 7 Coulomb, are placed at positions A, 0, 0, minus 15 centimeter, and B, 0, 0, plus 15 centimeter. Calculate total charge and electric dipole moment of the system. Here two charges are given. They are equal in magnitude but unlike. One is plus and the other is minus, and they are placed at different positions. So we are going to draw a figure for this. For that, I am taking this as x-axis, this as y-axis, then we know this will be the positive z-axis. So this is x-axis, positive, this is positive y-axis, and this is positive z-axis. So let us draw the negative z-axis also in dotted lines. Now we are going to mark points A and B on this figure. We know point A is 0, 0, minus 15 centimeter. That means x is 0, y is 0, but z is minus 15. So if I take this distance as 15 centimeter, then this point is A. So here it is 0, 0, minus 15 centimeter. So I got this point as A. And where will be B? It is 0, 0, plus 15. That is in positive z-axis. So here, so this point is B, that is 0, 0, plus 15 centimeter. At point A, we are having charge QA, and at point B, we are having charge QB. So they are separated by a distance. So this is a case of electric dipole. Now we are going to calculate total charge. We know total charge is the sum of the charges, that is QA plus QB. We know QA is equal to 2.5 into 10 raised to minus 7 Coulomb, and QB is minus 2.5 into 10 raised to minus 7 Coulomb. So the resultant is 0. So we got the total charge is 0. Now we are going to calculate dipole moment. We know the magnitude of dipole moment is P is equal to Q into D, where Q is the magnitude of one of the charges, which is 2.5 into 10 raised to minus 7 into D. D is the distance between these two charges. We know the distance from center to QA is 15 centimeter, and distance from center to QB is 15 centimeter. Therefore, the distance D is equal to 15 plus 15, that is equal to 30 centimeter. We know it is equal to 0.3 meter. So D is equal to 0.3. 2.5 into 0.3, that is equal to 0.75 into 10 raised to minus 7. We know the unit is Coulomb meter, and we can write it as 7.5 into 10 raised to minus 8 Coulomb meter. So we got magnitude of dipole moment. But what is the direction of the dipole moment? The direction of dipole moment is along the z-axis, or we can say it is from minus q charge to plus q charge. Here minus q charge is qb. That is from QB to QA, that is along negative z-axis. So we got the magnitude of dipole moment is 7.5 into 10 raised to minus 8 Coulomb meter, and direction along negative z-axis. Now we are going to study physical significance of electric dipole. We know there are positive and negative charges in a molecule. In most of the molecules, the center of positive charges and negative charges are lying at the same point. But there are some molecules for which the center of negative charges and positive charges do not coincide. They are called polar molecules. That is, in polar molecules, the center of positive charges and negative charges are separated by a small distance. So they behave like an electric dipole. So they have dipole moment. So dipole moment in molecules is a measure of the polarity of the molecules. One example of polar molecules is water. The other type in which the center of positive and negative charge are coincide are called nonpolar molecules. So in this case, center of positive and negative charges coincides. One example of nonpolar molecules is carbon dioxide. We can also see if these nonpolar molecules are placed in an electric field, the electrostatic force due to this electric field can separate positive and negative centers and thus develop a dipole moment. So if a nonpolar molecule is placed in an electric field, it also develops a dipole moment. So this electric dipole is having physical significance. So in this video we studied electric dipole. In coming sections we will study more about electric field due to an electric dipole. Thank you for watching this video. Keep learning. If you are not yet subscribed to our channel, please subscribe it. Also, please like and share this video.